Hello everyone, welcome back. Today we will discuss, we'll start a new chapter on something called community analysis in networks. This is perhaps the longest chapter of this course, but this is very important, a fundamental property that we are going to discuss today. So far we have learned different metrics to quantify a network. We have learned how to model a network, right? We have also learned how to quantify links in different ways, right? And we have also learned some of the properties that are often seen in real world networks. For example, scale fee property, right? Power law degree distribution, small world, high clustering coefficient, and so on and so forth. So similarly, community structure is one of such properties which is quite prevalent across different real networks, be it social network or information network, citation network, right, biological network, and so on. Okay, so let's get started. So let me ask a fundamental question that how many times your decision on watching a web series got influenced by your friends. I'm pretty sure most of you generally take suggestions from your friends to to watch a particular web series or to watch a particular movie, right? Also, I'm pretty sure that most of the times when you purchase a product, say from Amazon or from Flipkart, for example, you often talk to your friends to understand the quality of the product. You look at the reviews and so on. So in our real life, our decision of taking something or watching something or going somewhere else or going to a particular restaurant and so on and so forth, all these things are dependent on our neighbors' decision, right? We generally talk to our neighbors, we generally talk to our friends, communities, and then we take decision, right? And you may also see that when an unknown person, say, comes to a society, right, he or she always starts looking at communities where he or she can best fit, right? For example, say I am a Bengali, right, and when I go to any party or any society, I always start looking at friends who are also Bengali. So there is always a homophily. And this homophily property is something which attaches nodes having similar properties, right? Hopefully you remember we discussed something called associativity, right? Associative mixing and so on in the second chapter on network measure. And you can also measure homophily based on the associativity of a network. So the term homophily is very important, which basically says that nodes with similar properties, they tend to interact with each other quite frequently, and nodes with dissimilar properties, they do not interact that frequently, right? And because of the frequent interactions among nodes with similar properties, we often see that similar nodes oftentimes come together and form a close community or close group, okay? And this property, the dense groups or the close groups, in networks, these properties quite prevalent across different types of networks, right? For example, if you look at, say, Facebook, we see that we can also create communities, we can create groups, right? So remember, I use the term community, group, right, module, these terms quite interchangeably, okay? So in Facebook, we often see that there are existing groups, or you can also create your own group. Say, for example, you create Sachin Tendulkar fan club, right? Or say Lata Mangeshkar fan club, and anybody who is a fan of Sachin Tendulkar or Lata Mangeshkar, so they will basically join the group, and then you start discussing about their past activities, the songs, etc., right? And so this group basically defines certain attributes, and if you also have the same kind of attributes, you basically join that group and be an active part of that group, okay? So this kind of communities can be formed naturally or artificially. For example, in case of Facebook, you proactively create groups and then people start joining in. Whereas if you think of, say, user interaction network or a friendship network, where you see that groups like music club or a gym club or a department, right? These groups are basically created naturally. Say if you are fond of music, you go and join a music club, right? So homophily is the property for which we see community structure emerging on different social network, different social as well as other types of networks. So we generally quantify homophily based on the features, right? It can be age, it can be gender, class, religion, race, ethnicity, interest, organization role, and so on and so forth. Okay. So what is community? What is cluster? So as the name suggests, you also understand that when I talk about cluster, it means that there are groups which are densely connected internally, right? So community, the definition of community is not sacrosanct. There is no concrete definition of what is a community. Okay, it has a fuzzy definition, and therefore community analysis or community detection is an ill-defined problem. It is not a well-defined problem. Okay, so you can define community in your own way. Anybody else can define community in his own ways, and then you can start detecting communities in that manner. So what is a community? Generally, a community is defined by groups of nodes such that within a group nodes are densely connected, and across groups nodes are sparsely connected, not densely connected. Okay. So now if I define community in this way, then the natural question would be, what do we mean by densely connected? What do we mean by sparsely connected? Can we quantify that? Okay, after certain point, so how do we quantify density? We have already discussed a metric called age density, which basically measures the fraction of ages, right? It's basically a fraction of actual number of ages and the total number of ages, I mean the possible number of ages present in a particular group, right? So once you measure age density, then how do we quantify the meaning of highly dense or densely connected or sparsely connected? Is there any threshold after which we will say that okay, this is densely connected, and below which we say that this is sparsely connected? There is no such definition. Therefore, this is not a well defined problem as such. Okay. So it is good as well as it is bad. Why it is good? It is good because you can define your own way. You can come up with your own definition of communities, and you can write papers. Okay. And it is bad because since there is no standard definition, therefore it will also be difficult to convince others that the definition that I am proposing actually makes sense, right? So in that sense, this is difficult. Okay. So then how do people essentially deal with this problem? So what people do is they try to come up with a definition of a community, and of course it needs to be convincing enough, and then you detect communities from the network in some ways. Okay. So in the subsequent slides, we will define communities in different ways, and we will see how based on those different definitions, we basically extract communities from a large network. Okay. So what are the applications of community detection? It is useful for link prediction. So in the next chapter, we will discuss what is called link prediction. So basically the idea of link prediction is that let's say you have two nodes which are not connected at timestamp t. What is the probability that at time t plus 1 these two nodes will be connected? Can we forecast, can we predict the likelihood that two nodes which are apparently not connected at current point in time will be connected at next point, or say t plus 1 or t plus delta t time period? This is called link prediction, and how community structure plays an important role here. Say let's say let me take an example, right? Let's say this is the network. Okay, this is the network, and let's say you already know that this is a community, this is another community, and this is another community. There are three communities. Okay, and the question is, can we predict that this node, say node A and node B, these two nodes, so they are not connected at current time period, okay. What's the probability or what's the likelihood that A and B will be connected later, okay. So if you know the community structure, you can say that look, A and B, right, they are part of the same community, therefore it means that A and B exhibit same kind of properties or same kind of same kind of structural or functional properties, right, therefore they are part of same community. So this is highly likely that in the future A and B will also be connected. So if you know the community structure and if you know that these nodes are part of a community, and if those nodes are not connected at this current time period, it is highly likely that at t plus delta t time period they will be connected, okay. So community structure plays an important role for link prediction. We will discuss more in the next chapter. And of course link prediction, one of the applications of link prediction is recommendation system, right. For example, product recommendation system or movie recommendation system, right, it is also a link prediction task. So of course then community will also help in in recommending products to certain users or movies to certain users, okay. The third application is information diffusion, okay. We will discuss in one of the chapters later that if information starts spreading from a particular node, and if I know that this node belongs to a particular community, so it is highly likely that the information will first spreads within the community. So the nodes which are part of the same community, they will be affected first, they will be exposed to that information first, and then that information will move from that community to the other community, okay. So if you know that within a community these nodes are part of, it is highly likely that those nodes will be affected by the information first compared to those nodes which are not part of this community. It is useful for marketing strategies. For example, we discuss something called targeted advertisement, right. What is targeted advertisement? Let's say you have built a product for youth, right, or you have built a product for a certain region of India, okay, and you want that part of the network will get exposed to that particular product, okay. So if you know the community structure, what would happen is that you target that community where your potential customers belong to, and you basically start probing them, okay, start convincing them to buy your product, okay. So this is useful for targeted marketing, okay. This is also useful for restricting the epidemic spread. If you remember, we discussed in one chapter in one of the previous chapters is that there are nodes which are called gatekeepers, okay, and gatekeepers are generally those nodes which connects which basically connect two communities in a network, two or multiple communities in a network. So if we know the communities, it would be easier for us to understand, to identify the gatekeepers or articulation points, and then accordingly we will vaccinate. We will vaccinate those users so that the epidemic will not spread from one community to the another community. This is also useful for anomaly detection. Again, in one of the chapters later, we will discuss what is anomaly. So anomalous nodes are those nodes which do not look like normal nodes in a network, okay. And again, when you define anomalous nodes, we generally define with respect to a particular community, okay. Let's say there is a community of students where all the students or the most of the students are PhD students, right, but there is one student who is a master student, right, but all of them belong to the same community. So all of them say belong to the same research group, right. So with respect to that community, the master student is an anomalous node, okay. But with respect to the overall network, there are many other master students. So overall that node is not an anomalous node, not an outlier node, but with respect to that community, it's an outlier node. So if we know the community structure, you can detect anomalous entities in a network in a better way. You can also study the evolution of communities. What do you mean by evolution of communities? Let's think of a scientific network, say citation network, okay. And in a citation network, generally communities are different research areas. Say in computer science citation network, you can think of AI, database, right, algorithm and theory, right, say robotics. These are different communities. Okay, and then you look at how, over the times how this network changes, and at the same time how these community structures change, meaning that how new nodes are coming in. Since citation network is a growing network, it will never it will never the number of the size of the network will never reduce. It is a growing network. So we basically look at how nodes are coming in within communities and how interactions are happening across communities and within communities, right? And depending on that, you can also decide which fields are going to be merged together to form a new interdisciplinary field in the future, right? In fact, there are studies. We also did a study where we showed that how, computer science, if you track the citation network of computer science, how fields like NLP or fields like computational biology, these are all interdisciplinary fields, right? How these fields emerged, from the cross fertilization of, these communities like AI, database, theories, and so on. Okay. Of course, this is useful for criminology to detect terrorist groups, because if we know that in a society, generally these groups are legal groups, or these groups are, this group should be there in a network. You can identify those groups which seem to be quite abnormal, anomalous, and that can help you detect those fraud users or criminals from a network. Okay. There are many applications. The community structure is something which is used almost every application in network science. So let's now try to understand what's the task. What's the task that we are looking at here. So we are given a network like this. Okay, so this is although it's a small network, but again, even if you look at this network manually, you won't be able to understand the clusters, right? And what's the task? The task is to group nodes from this network, right, in such a way that these groups basically form different communities. So community detection is nothing but grouping nodes in a systematic way, so that we see, right, this module structure in the network properly. All right. So why do we care about detecting community structure? We have already discussed, but still there are theoretical reasons, there are practical reasons. So let's look at the theoretical reasons. So if we know the community structure, it would help you understand the organizational blocks of a system. For example, if you think of user interactions in an institute, right? So in an institute, you can think of these communities as different blocks, as different organizational blocks. For example, one block can be an academic block, one community can correspond to a sports block, one community can correspond to library block, and so on. Because within a block, within a community, users generally interact quite frequently compared to across blocks. Okay, you can actually infer node features if you know the community structure. How? Let's say in this particular network, say let's take this community, right? And let's see, let's assume that the node features, right? For example, the demography, the age, the gender, and so on of this node, and this node, all three yellow nodes, right? But you do not know the node features of these three red nodes, right? You can infer the node feature based on the known node features. Why? Because since we know that a community is formed due to the homophily nature, therefore it is highly likely that these red nodes may also exhibit the same kind of properties, same kind of features that the yellow nodes have. Okay? You can also classify nodes, because essentially community detection is a clustering technique, right? It's a clustering problem, and clustering of a graph, clustering of a data set is nothing but an unsupervised classification task, right? So you basically group nodes into different clusters. So in that way you can classify nodes. Okay? You can also predict missing links, okay, or link prediction, the one that I mentioned, right. Say for example, you want to predict whether this node and these nodes are connected or not. So what happens is that when you scrape data points, when you scrape data from social media, for example Twitter, Facebook, what happens is that we sometimes may not be able to scrape the entire data, okay, because of different reasons. For example, there are problems in the crawling process, there are problems in the there are different restrictions, security restrictions. For example, some nodes are private, right, some edges you may not be able to look at, right. So those information you may not be able to curate properly. So it always happens that when you scrape data sets, some edges, some nodes will be missing, okay. So if we want to make it a concrete data, you need to predict those missing links, right. Remember, missing link and future link, these are different problems. We will discuss in the next chapter, but missing links basically is, missing link prediction, is a task where at current time you want to understand or you want to detect whether a link exists or not. And future link prediction is basically says that, can we predict at time t whether a link will come or a link will be formed at time t plus delta t. It's more of a forecasting, okay. So let's say you want to predict whether node A and node B, these two nodes are connected or not, right. Is there a missing link between A and B, okay. You can say that if you know the community structure, you can say that it is less likely that A and B are connected. Why? Because A and B are part of different communities, so it is less likely that they will be connected or they are connected at the current time period, okay. Of course, community detection has practical applications. Recommendation system, you can earn money, okay. For example, this product user product bipartite network. So this is a bipartite network. In one partition you have users, another partition you have products, and you basically want to predict whether this user will buy. You also know that all these 4 users belong to a community and these 2 users belong to another community. So, and in this particular community, the user 1, user 2 and user 4, all 3 users have already bought this bread, right, and some other fruits and ham, right. It is also and this guy has not bought ham so far. Since this guy also belongs to the same community, you would actually recommend ham, this product, to this guy, because the other other users who are part of the same community, they have already bought ham. So it is highly likely that this guy will also like to buy ham, okay. So why it is a difficult problem? Let's try to understand why community detection is a difficult problem. So if you think of it in a careful manner, what it is about. So let's think of this network, right. There are 15 nodes you see here. So you can create this adjacency matrix, 15 cross 15 adjacency matrix, and you basically have ones corresponding to those pairs which are connected, and these other places are zeros, okay. I have not added zeros because if we just add 0, this would be a little clumsy, okay. So these empty points, empty entries, these are zeros, okay. This is a sparse network. So community detection is nothing but adjusting the adjacency matrix in a different manner so that you get this kind of structure, okay. And this is called block diagonal matrix. This is called block diagonal matrix, okay. Why it is called so? If you look at the blocks, so if you look at the diagonal elements, this is the diagonal elements, you see that there are blocks, right, blocks of ones, okay. These blocks correspond to different communities. For example, this red block corresponds to this community, this one corresponds to this community, and the yellow one corresponds to this community, okay. and therefore all these ones within a block, these are basically intra-cluster, intra-community edges. Okay, and what about this green numbers, green ones? They correspond to inter-community edges, right? There are 1, 2, 3, 4, 5 inter-community edges. So you will basically see inter-community edges in this modified adjacency matrix. Okay, so its basic community detection is basically a switch to convert a raw adjacency matrix to a block diagonal adjacency matrix. Okay, I mean, one may argue that what's the problem here? I mean, we can essentially swap rows and columns in a systematic way, and we can easily get this kind of block diagonal structure, right? We do not need any algorithm. But think of a large network, right? Million cross million adjacency matrix. How do we manually get this kind of block diagonal structure, right? So we essentially need certain algorithm which basically convert a raw adjacency matrix to this kind of required adjacency matrix. Okay, and this is basically about community detection. Okay, so we stop here. In the next lecture we will continue with the different types of the community structures, and we will also discuss different algorithms that we generally use for community detection. Thank you.